Okay, section 1.4, angle measure. This is something you've all dealt with before, but at the same time, there's a good chance that you may not quite understand what you're doing as far as, or what you were measuring. We're used to measuring things along a straight line, are we not? Okay. You know, when we're measuring stuff, the distance from this to this is that to that. Okay. Angles, we don't measure along a straight line. This is an angle. Okay. This angle I measure it up. I'm going to get it straight right there. What does that say? It's kind of hard to read, but 34 to 35 degrees, wouldn't you say? Let's go with 35 degrees. Okay. Now, what is this thing right here that I'm going on? What does it make? What am I making over and over again? A circle. That's how we measure angles. Degrees along a circle. As I get to there, it's what? 90. As I get to a flat line, it becomes what?
180.
And I go all the way around again, I end up getting to what? 360, which is what a circle is it not? Everybody good with that? Okay, so this is a 35-degree angle. And where you'll see this written lots of times is you'll see it written right here, and they'll say that's a 35-degree angle. Zoom in on that a little bit. An angle is made up. These are what are called rays. Two rays. Say that was point A, that was point B, and that was point C. Okay? The sides of the angle is ray, BA, and ray or side, BC. Notice how I only have one arrow on ray? What's the vertex of the angle? Anybody? The vertex of the angle is B. If you were to describe the vertex, what would you describe it as of an angle?
The corner,
Like the corner. Yeah, there's all kinds of different ways you could describe that. Where it kind of changes directions, right? Kind of what creates the angle. There's all kinds of different ways we can describe that vertex. Okay? But this vertex is important. Now, over here to the side. How could we name this angle? I'm going to put a 1 here and I'm going to put a star beside this because this will always, always work. What you can do, you name using angle, then you go point on one side. Well, that's a little odd. Then vertex, then point on the other side. All right, guys, so what did I just say there? Okay, did you hear what he said? He said angle A, B, C. What you do is you use this thing for sign for angle, A, B, C. You guys see how that makes sense up there? Anybody see another way I could name it that way? But you could not name it angle BAC. I know why.
Because it's not going with what you said. It's going from the vertex out.
Right. Here's, everybody look up here. If you haven't quite got this written down, remember I'm always going to post it. And we're recording now, so I'll post this video. If you'll look up here, what I try to tell people when you're trying to figure out how to name an angle or what angle they're talking about in a problem, put your pencil down and they will name it how you would draw it. If I was giving you directions how to draw this angle, I would tell you to start at what? A, right? Then go to what? Then go to what? Did I just draw that angle? You guys see what I'm saying? That works out. The other way I could do it, I could say start at what? C, then where do I need to go? And then where do I need to go? And that draws the angle. However, if I told you to start at B, everybody look at the picture, and then go to what? And then go to, did I draw that angle? I didn't, did I? If I told you to start at A, then go to, did I draw that angle? But the confusing part isn't as much when you have a picture and I ask you to name it, it's when I give you the name and you've got to go find it on the picture, which we'll get into in some of our examples. Don't write this down, but if I was just to write all those written down together, does it look kind of confusing? If you look at it just that, and you don't take the time to maybe draw it with your finger or whatever it may be, who knows which one of those? In fact, what's the only one of those that works? The top one. The key is the vertex right there, B. Okay? You guys get my point. This is something that kind of messes with people, and that this is something people have problems with down the road. Reason being is they really don't like to have to go through putting your pencil down. It takes too long. Well, I'm sorry. To this day, when you come up and ask me a problem and they say angle ABC, in my mind, I draw it to make sure I'm talking about, I'm referring to the correct angle. Because there's just too many factors that could change from this one to that one, or you know what I mean? It's So you've got to make yourself do that. Sometimes if there is no conflict, you can name by the vertex only. So what would be the name here? Angle what? And that would work here. Why do you think it would work? Would there be any, and I'll tell you why, would there be any confusion what angle I was speaking of when I'm talking about that? Any confusion at all? Is there any other angle? Oops. Is there any other angle that has that as its vertex? That has B as its vertex? What do you guys say? Yes or no? Put the phones up, everything up. I'd know exactly what angle you were talking about. Now, let's say there was another line coming out here, and that was a D. Now, could I call the 35-degree angle angle B? Huh? I couldn't actually. You know why? How many angles are there? There's actually 3 if you include the large one, DBC. Right? Now there's angle DBC, the big angle, right? There's angle ABC, and there's angle DBA. So when I would just say, if I just said angle B there, would you know exactly which one of those 3 I was referring to? No. So you could not name it that way in that case. That's why, keyword there, sometimes. The last way, sometimes a number will be put near the vertex to denote that angle. Okay, and a different color pen, if you saw a 1 right here, you guys see how I wrote a 1 right there? You might see that called angle 1. You guys see the 1 I wrote in there? I wrote it pretty small. That won't always be done though. Once again, I could have, and don't draw this, I could write 2 there and 3 there, couldn't I? When you see a bunch of these written together like that, you'll see them sometimes label them like that, which is nice. It's very easy to see. You know which one's angle 1, don't you? You know which one's angle 2. You know which one's angle 3. However, the reason that's still not foolproof is what about the big ones there? I mean, where am I going to draw a 4 to denote that angle? Agreed? Where am I going to draw a 5 to denote that angle? Make sense? So the most foolproof way is the way that everybody hates, that can be sometimes confusing, that way. Because you know exactly what angle you're talking about. Undo. Undo. There we go. Any questions? I know that seems like I'm spending a lot of time on not very much, but like I've told you guys over and over again, naming these angles is sometimes the hardest thing. Okay? Any questions on that? Right now, just look up here. Don't necessarily write this down. You can write it down later. Okay. I'm going to draw a couple of different situations here. Give myself a little more room here. I want to talk about two separate situations here. On this one, if this distance was 50 and this distance was 80, what is the distance from A to C equal to? Huh?
130.
How'd you get that?
I added it.
Does everybody understand that? It'd be 50 plus 80, right? Because that's that distance, correct? And that's that distance. Is everybody okay with that? Okay. Now, what if this angle was 50 degrees and this angle was 80 degrees? First of all, I do need to talk about this. In other words, what I'm saying is that the measure, see, I put that little M in the front? That means measure. Another little kind of abbreviation, lazy way. They don't want to write the word out measure, so we put a little italicized M there. The measure of angle, let's say ABC. Can you guys tell me what that is? What am I talking about in measure ABC? I'm talking about A to B to C, and I've got that labeled as how many degrees? Is everyone in agreement? Any questions there? Okay. How about the measure of angle DBC? What is it equal to? Good. My question to you guys is, what is the measure of angle ABD?
130 degrees.
A to B to D. I heard 130. How'd you get 130?
Added them together.
Well, you guys did good. What happens, for those of you that are confused, a lot of times people have no problem saying the two smaller parts equal what? The whole thing here, right? But because we measure angles along kind of a circle, it sometimes confuses people that the two smaller parts still equal the whole thing in the same aspect as far as angles are concerned too, right? A lot of times when I say I'll do this and say that's a 50-degree angle, and then I'll say do that to denote that's a what? And sometimes kind of write it like this. What am I trying to help you guys realize? That it's measured along a what? And so it makes kind of, when you look at it like this, doesn't it make sense that then the whole thing is 100 and what? Does that make sense? Like I said, basics, which you would be amazed. If you don't learn this from right now, you'll be in trouble. Okay? Write that down right quick. That looks better, doesn't it? That's not stretched, is it? Let me know when you guys are done writing that down. And we'll go to the practice workbook. Actually, I'm sorry, we have one other thing, a couple other things. Is everybody right here? This is absolutely positively review. I guess I'll write the word out the first time. You guys remember these three?
Yeah.
What's an acute angle?
Smaller than 90 degrees.
Less than 90 degrees. What's about right angle?
90
Equal to 90 degrees. What's an obtuse angle?
larger.
Greater than 90 degrees. And by the way, you will see me, instead of writing the word angle out, what do you see me think I'm going to put all the time? That little angle sign. Everybody got the top stuff? Last thing. Say this entire angle. $120. So what I'm saying is the measure of angle what? ABC is equal to what? 120 degrees, correct? What does it look like I was trying to do with the red ray I drew there? Kind of looks like I'm trying to cut it in half, doesn't it? Well, BD is called an angle bisector if it cuts the angle in what? Half. So that would make this measure what? 60 degrees, and this one what? And you know what we call those? We call them congruent angles. And you know what's, we put that right there to denote that they're congruent. See that little arc? If we wanted to denote more than two different, we'll put two arcs to denote two other ones, you know, right above each other. Like sometimes you'll see it like that. That means the ones with two arcs are what? Congruent, meaning the same size and shape, right? Any questions there? Okay, now we're done and ready to go on to some examples. I know we're going long today, but this is, I told you guys, notes will be long this time of year because, mostly because, to be brutally honest, we have got to get these basics down or you will struggle the rest of the year. How hard would it be to pass an English class if you didn't understand English? Pretty hard, huh? You got to learn a little bit of the language here or we will struggle. You will not be able to get to understanding something because you can't get past, I don't understand what in the world they're talking about. Let's wake up. Let's not lay down. Okay, so now we're going to pull up and do a couple examples here. These are type of problems you're going to have a great deal of in here. In this section, you're going to need to draw good figures. Write the problems out because there's not much figuring to do. Name the vertex for angle 5. So I go over here. Where's angle 5? Isn't that angle 5 right here? Would you guys agree? What's the vertex of angle 5? That was hard. I don't even have to look at this one right here. I don't even have to look at the picture. Why don't I? It's M. Why? It's NMP. So N, and the second letter is always what? The vertex, P. You can see how this can get confusing if you don't like trace it and things like that. Agreed? There's a lot, you know. NMP is this big one. It's the when 4 and 5 are combined, correct? So it's M. Everybody got that? I don't want to spend too much time on that. We don't have a bunch of time left. Name the sides of each angle. Angle 6. What are the sides? And you can put these as segments. They don't have to be as rays. Angle 6. So I've got this side and this side. What are the two sides of angle 6? NM, right? And what is this one called? You guys okay with that? Or I could call it NP, couldn't I? Or NR, couldn't I? Those are the sides. The sides are segments or rays or, okay? Segments or rays, not lines. So write them as segments. That's where you'll see them written most of the time. That's easy. Write another name for each angle. QPR. Q to P to R. What's another name for that angle? Angle RPQ. Give me another name. Angle 3. You could not, angle P would be wrong. Can anyone tell me why? I wouldn't know which one you were talking about, whether you're talking about 1, 2, or 3, or the other one there, right? Everybody okay there? Use a protractor classified as acute, right acute or obtuse. I have protractors up here you guys can use, but I think you guys can do this, can't you? You guys understand that you put the vertex, or you put the circle there, then you line the line up there, then you see where that stops on the protractors. Everybody done that before? Okay. Now to the fun stuff. Let's see. We say CB and CD are opposite rays. What does that mean? This is something we'll talk about again tomorrow, but that means it's a straight line. Do you guys know? This is one of those things you can look at a picture and always know. Do you know what the measure of that angle's got to be? That is the one thing that you can look at a picture and get. Okay? So you might write that, or make sure you write that down in your notes, that opposite rays or straight lines, the angle is what? 180 degrees. So anyway, no matter how, if I drive a straight line, what do I know those two angles add to? No matter how I draw this straight line, what do those two angles add to? I don't care how I draw this thing. What do those two add to? You get my point? Very important. Something you will use over and 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 over again. There's just so much information in this section that we'll go over that fact again as well. It says CE bisects DCF. So let's go over. See, I can write down the things. No, CE bisects DCF. So what does that mean? That is congruent to what? You guys agreed? Okay. What else is the problem? GC or CG bisects FCB. FCB GC. So this one bisects this one too. Now, it doesn't mean that it's necessarily congruent to the other one, so I have to use 2 marks here. You see now the difference? The ones with 2 marks I'm saying are the same size, congruent, correct? The ones with 1 mark I'm saying are congruent. So now let's go to see something they give us. Oh, what does this problem look like? Number 15 looks like what? What do you think of when you see an x plus 4x plus 15? What class do you think of? Algebra. What do we probably need to create?
An equation.
So 4x plus 15 is DCE. So I'll go over here, DCE. Just write it right there. Okay. ECF is 6x minus 5. ECF. Okay. What did they ask me to do? Find DCE. And they want me to find the measure of angle DCE is equal to this. Well, I'm going to use this picture, and over here to the right, we're going to solve. I need to create an equation, correct? How does the two quantities that have been given to me relate to each other? Do they add to something? Or are they equal? Oh, okay. They're equal to each other, are they not? Because I said they're congruent. So 6x minus 5 is equal to what? 4x plus what? What am I now going to do? I need to find x, don't I? But it says to find DCE. Well, if I find x and I put a number in there, can I solve it? What do I need to do to solve this? I'd have 2x minus 5 is equal to what? 15. What am I going to do now? And I get 2x is equal to what? What am I going to do now? X is equal to what? Wouldn't it be terrible to go through all of that? You did the smart thing, you made the equation correctly, but you didn't pay attention to what the directions were asking you for? They asked you for what?
The angle.
Angle DCE, and I promise you on a multiple choice test, 10 will be one of the possible solutions. Well, what you need to do is put it back in. Well, DCE is 4 times whatever what? X is plus 15. What is X? So that's 40 plus 15. So the answer is? Okay. And there'll be some where you have to add to, and I'll help you with those tomorrow and stuff. Okay. Now, on the left there, you guys see your assignment?